So in this class, we're going to talk about data types in Python. So what are data types? These are basically the way or the the type of data that we have in Python. Right? In Python, we have couples of data that comes along with Python, and we have the one that is user defined. So there's a system defined data types, and there's your user defined data types. So the first data type we have in Python is your text type, which is your string. The second one we have is the numerical type, which is your integer, your floats, and your complex numbers. These are all number data type. The next data type we have is your sequence data types, which are your lists, your tuples, and ranges. Then you have your map data type, which are your dictionary, your set data type, which are your sets and frozen sets. Then your boolean data, which are your true and your false. Then you have your binary data types, which are your byte arrays, and your memory views, and then your non-data types. Right? So these are the key. So these are the key data types we have in Python. Okay. So we'll go into each of them and learn a little bit about how they work and when to use them. So the first one we are going to talk about is the integer data types, which is short for int, which is int. These are all numbers, either positive or negative, without a decimal point. Right. So anything like 5, 1, 2, 3, -5, all of those things are integer data types. Right. Before we move any further, let me just clear up my console and we'll start from here. If I cleared it, should have been cleared out. Okay, perfect. So to check the type of data that is stored in a variable, you simply use the type keyword followed by the variable name inside of the parentheses, right? So when I run this, I'm going to get the type of data that is stored inside of here, which is your integer data type. You can get the data type of any object using the type function, right? So the next data type we have is the floating point data type, right? These are numbers with decimal values. In programming in general, we have numbers that have decimal values and the point moves from the left to the right. That's why it's called a floating point. It simply moves from the left. You can have it here, like this. It could be here. So the point can move here. So this is a point. It can also float to this direction. And I'll have to take this one off. Okay, so all of these are floating point, right? So your computer identified it as a floating point data type. So to check it out, to make it to know if it's actually a float, you have to actually run this and put it inside of a type and it will give you the value. So a floating point can be any negative or positive value that has a point in anywhere in that particular value. So let's run this. So you can see that this is a floating point data type. There are some extra key values, like some special values for floating point, which you have your infinite, your negative infinity, and your not a number, which is NaN, right? So this stands for negative infinity and positive infinity. Right? So these are also categorized under your float data types. So the next one we have is your complex numbers, which allows you to add imaginary numbers to your real numbers. So to check this out, you simply paste the numbers inside of your types and put it here. So necessarily you won't get to really use this as a data analyst, but going forward, when you keep improving and going higher in the ranking of data science, you get to learn and to use this a lot more. So one thing you notice about data is that you can convert from one data type to another, right? But you don't do that for all data types. Okay. So for the numerical data type, I can convert from a float to an integer back to a float, and from an integer to a complex number, but I cannot convert from a complex number to any other data type. So as you can see, it's an integer, a float, a complex number. You can convert the float. So I can convert the integer to a float, convert the integer also to a complex number. Let's do this. And when I run this, I'm getting, you can see I'm getting this complex here. So when I convert this, which is a float, an integer, to float, it gives me the float that is now a float. Convert from float to integer using the integer function, it gives me an integer here, and I can also convert from the integer to a complex number, and it gives me the complex number. Notice you cannot convert from a complex number into any number data type. So if I try to convert from this complex number to an integer number, I'm going to get an error. So you see the error, argument must be a string, a byte-like object, or a real number, not a complex number. I cannot convert from a complex number to any other numerical data types. So the next data types we have is your sequence and your iterable data types. And under this, you can have your strings, your lists, your tuples, and your, that's basically your lists, your tuples, that's your sequence type. And also your string can also be categorized as your, see, your string can also be categorized as your text data type as well. It's a sequence data type and it's also a text-based data type. So to know a string, it's normally close with two quotes to know it's a word, it's a sentence. It's a word, a character, a sentence. So it's closed with the two quotes. And if you check the type, you can signify using the str, which is short form for string. Then the next data type you have is your list, which are just a collection of data types that are combined into one. And then you have your tuple, which is also a collection of data types, but the difference is that I cannot change, once I create a tuple, I cannot change the values of that tuple. It's done, it's done. Most things you store inside of tuple are values that do not change. For example, the days of the week. By default, the days of the week do not change. So the next data types we have is your map data types, which are your dictionary. Right? This stores values in a key and a value pair. Right? For example, we have your name, which is the key, then the value can be the name John, age, which is your key, then the value can be the age 30, and so on and so forth. And if you want to refer to your name, you can just, if you want to get the name John, you can just refer to the name key and you get your name John. We should dive into this more going forward. So you can see it's the data type as dictionary. So you'll notice that you have curly brackets, then your key, your value, then comma, your key, your value, and so on and so forth. The next one we have is your set. Sets are unordered collection of unique elements. You have your values in your set, and to create a set, use the curly brackets. Then when I run this, you see it removes all duplicates. That's one advantage of a set, which we'll get to find out more as we go forward. The next thing we need to understand is our boolean. The booleans are used when we want to denote true or false values, right? That's when you use your booleans. An example for boolean is the true value or the false value. So this is a boolean. When I get the type for this, I'm going to get boolean, and I also get the type for this false. I'm going to also get boolean. Then I can do a print of it to get it as a class. And this you can see it's a boolean class. So the next item, the next data type we have in Python is your non-data type. In Python, a non is a special data type that is often used to represent a missing value. So a variable that you don't know the value during the time of inception or the time you are going to declare that variable, you can use the null as a placeholder for that value. So this x variable is equal to none. This would allow me to have this variable x without any value. Then I can subsequently attach a new value to it. Right? So when I run this, I'm going to get null. But if I come here and reassign a value of 2 to this, I'm going to get an integer, right? So this allows you to create a variable and reassign the value to it later on. I cannot create an empty variable like this. I'm obviously going to get an error, right? So that's why I have to apply the null to it, so it can act as a placeholder until I assign the correct value to that my x. So far, we've understood most of the data types we have in in Python. We know how to effectively write our codes and our data types. This should allow us to know what data we are using for each instance of our code, allow us to easily manipulate our data and create beautiful codes and analyze our data based on the type that they are. So now that we've understand this, we can go to the next lesson and I'll see you in the next video. So do practice what you've learned so far.